Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 16, 2026, exactly 1 week ago. It challenges the common belief that adding languages hurts AI performance, showing that with better data curation, models trained on just 1 trillion tokens can match or beat baselines that use 4 to 10 times more compute. The paper is titled ÜberWeb, Insights from Multilingual Curation for a 20 trillion token dataset. And, as we'll see later, the implications for building efficient multilingual models are quite significant. So Figure 1 illustrates this new efficiency frontier directly. These 4 panels plot model error rates on the vertical axis against training flops on the horizontal axis, covering benchmarks like Multilingual MMLU and ARC. The shaded gray region captures the performance envelope of strong open-weight baselines like Llama 3 and Quen. Crucially, the Datalogy AI models, shown here as cyan squares and circles, sit consistently below and to the left of this curve. This positioning implies they achieve competitive accuracy while using roughly 4 to 10 times less compute than those larger baselines. To achieve those efficiency gains, the researchers focused on the 13 non-English languages listed here in Table 1. This selection intentionally spans a wide variety of language families and scripts, from Germanic and Romance languages using Latin characters to others like Chinese, Arabic, and Hindi that rely on completely different writing systems. The columns on the right highlight a critical challenge, the massive imbalance in data availability. While high-resource languages like Russian and Chinese offer hundreds of billions of tokens, low-resource ones like Bengali are scarce, providing a perfect testbed to see if data curation can bridge these gaps. Having defined the language set, Figure 2 now quantifies the impact of data quality on performance. The chart tracks average scores across all 13 languages. The dark purple bars represent a fully uncurated baseline. The light blue bars reveal a fascinating result. Curating only the English data improves performance in the target language for 12 out of 13 cases, proving that high-quality English data aids cross-lingual transfer. Finally, the tall dark blue bars show that curating both English and the target language yields the maximum benefit. While the previous figure showed that English curation generally lifts performance, Figure 3 reveals that the benefit depends on linguistic similarity. Panel A on the left plots the improvement against embedding distance. Languages like Spanish, in the top left, are mathematically close to English and gain nearly 14%. In contrast, distinct languages like Bengali, at the bottom right, see minimal benefit. Panel B confirms this trend using perplexity, proving that English data's transfer power fades significantly as linguistic distance grows. Since linguistic distance limits direct transfer, Figure 5 explores whether we can bridge the gap using machine translation. These panels track training progress for Hindi, Bengali, and Arabic over 60 billion tokens. The bottom gray and cyan lines indicate that translating random English documents offers almost no improvement over the uncurated baseline. However, the purple dashed line performs significantly better, showing that source quality is crucial when using translation. Even so, the solid blue line at the top confirms that bespoke native curation still outperforms any translation strategy. So Table 3 lists the precise resource requirements for each model. The top 2 rows highlight the Datalogy AI variants, which achieved their results using only 1 trillion training tokens. If you look further down at the baselines like Llama 3.2 and Qn3, you see they consume anywhere from 9 to 36 trillion tokens. This huge gap in data efficiency keeps the Datalogy training compute in the 10 to the 22 flops range, whereas the stronger baselines demand up to 10 to the 24. Well, Figure 9 visualizes this efficiency gain language by language. Here, the horizontal axis tracks the number of training tokens for specific languages like Spanish, German, and Hindi, while the vertical axis measures downstream performance. The Datalogy AI models, shown in cyan and blue on the far left, used only about 6 billion tokens per language. In contrast, baselines like Llama 3.2 and Small LM3, scattered to the right, relied on hundreds of billions. Despite this massive data disparity, the Datalogy models consistently match or outperform the heavier baselines, effectively proving that curation beats raw volume. Wrapping up, 2 key insights emerge. First, the curse of multilinguality stems from poor data quality rather than model limitations. Second, precise curation enables models to match state-of-the-art performance while using 4 to 10 times less compute. This suggests we can build inclusive, high-performance models without needing massive resources. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.